Ever look really closely at the fabric on your sleeve? See the pattern, the weave, and the texture. The high-speed loom does it all. Look over your shoulder. A silent spy may be tracking you. The micro drone has moved up from amateur to professional. It's a monster lumberjack. Grab, slice, and stack a bunch at a time. Meet the Feller Buncher. A low-level rescue flight over water, rocks, and land. Speed, turn, stop on command. It's the sports car of Hovercrafts. Let's look inside these machines and see how they work. Weaving has been around since the early Stone Age. The basic concept hasn't changed, but speed and sophistication sure have. To keep us all in clothes and bed sheets, we need millions of kilometers of fabric every year. Impossible without the industrial loom. High-speed machines all over the world, like these outside Leeds, England, produce just about anything we need and want. Let's see how they work. First up, the basics. Take 2 sets of threads. The first is called the warp, 2 rows stretched lengthwise. The second set is called the weft, and it goes back and forth between the warp. Every time it goes through, the warp moves to trap the weft. The threads are now becoming a piece of fabric. To keep it from unraveling, a reed pushes the threads together. And then, the whole process starts again. To mass produce a wide range of fabrics, you need to organize thousands of different threads. So, the loom needs a lot of control. And it gets it from these devices called heddles. Each one has an eye through which individual warps are threaded. This gives the machine control of thread movement. Heddles are suspended on the loom's shafts, located here. When a shaft is raised, the heddles go up and the threads with them. To create simple patterns on one of these, you need a few hundred heddles and 2 shafts moving up and down together. Industrial looms have thousands of heddles and up to 24 shafts, all moving independently. That takes care of control. Now let's see how speed works on this machine. To manufacture massive amounts of fabric in a cost-effective manner, the loom needs to rocket the weft through the warp. Old-style looms use a shuttle, a spool of thread that unravels as it moves manually back and forth. Reliable, but slow and in constant need of reloads. This presents 2 challenges for the modern loom: how to weave thread quickly without a shuttle and spool, and how to minimize thread reloading. Enter the rapiers, one of the latest shuttle replacements. One rapier picks up a piece of thread, pulls it to the middle of the warp, and hands it off to its partner. It pulls the thread the rest of the way, while the first goes back for another strand. And because spools no longer have to travel back and forth, the rapiers draw thread from large bobbins. That means a lot fewer pauses for reloading, and this dramatically improves the machine's productivity. On the industrial loom, this handoff happens over 1,000 times a minute. This speed puts tremendous strain on thread snatched off bobbins at up to 250 kilometers per hour. If it breaks, the machine shuts down, and that costs money. So experts came up with a pre-winder, a device that preps thread for the rapier. It's a buffer that eliminates thread-breaking tension on the machine. Another side effect of speed is fabric dust. And to protect workers, it's got to go. Ceiling-mounted vacuums suck up the entire volume of air from the shop every 2 minutes. Okay, the loom is lightning fast, but how does it create different patterns and textures? A geometric pattern, like this plaid, starts with loading the warp with rows of different colored thread. Send a dark thread through the colored rows, you get this. Send a light thread across, you get this. The trick is switching between colors on the fly, and for that, it needs a Weft presenter, a component that selects different colors from bobbins and hands them off to the rapiers while they work. For complex patterns, a loom with a Jacquard attachment is required. It's a mechanical wonder. The Jacquard device controls all the threads loaded into the machine. Instead of ganging them together onto the shafts of a standard loom, every strand has its own control system. So, with a Jacquard attachment, operators can control the paths of each thread into ornate designs. Instructions are sent to each individual thread as it races through thousands of weaves. All those tiny decisions add up to a pattern, kind of like how a bunch of pixels become a picture. Its namesake, Joseph Marie Jacquard, invented the first of these mechanical marvels in 1801. Until then, this kind of work had to be done by hand and was extremely expensive. His machine used punch cards to control individual threads, and some consider it the first computer ever built. Which is exactly how its modern descendant works, only electronically. Designs and patterns are programmed into the machine, and away it goes. The threading of a Jacquard loom is so labor-intensive, it's usually done just once. When it's time to change colors, new threads are tied on to the existing ones. Even for a small loom with only a few thousand ends, the process can take days. Without these fabric workhorses, the cost of a single suit would leave most of us in last year's deerskin. The loom's a machine to be thankful for. It literally puts the clothes on your back. This is a hovering, unmanned aerial vehicle. The micro-drone MD4-200. Drones like this one are used for jobs like aerial mapping, fire inspection, law enforcement, surveillance, and search and rescue. Weighing less than a kilogram, its onboard camera records from a height of 150 meters. It's an eye in the sky that saves money and lives. Let's see how it works. The MD4 flies with the help of 4 fixed-wing rotors, each attached to an electric motor. You start it up, spin the blades, and up it goes. The design challenge is to keep the craft super light and whisper quiet, airborne and stable, all while transporting an HD camera. And to avoid losing it, program it to come home on its own when low on power, and land safely. When you tip the scales at less than a kilo, you don't need a big engine. That means less energy to fly and hardly any noise. To keep it light, designers chose carbon fiber for the MD4's body. A material born in the lab, made up of thin threads of carbon atoms in a hexagonal pattern. Weave it into fabric, create lightweight material with tons of strength. Small servo motors give the machine lift. All electric, without gears, the servos have more than enough power to fly the MD4. The 4-rotor platform keeps a horizontal and stable base in balance for taking pictures. That's the good news. But flying a quad rotor isn't like working a plane or a helicopter. 4 rotors means 4 sources of thrust, each needing constant adjustment. The motors are independently controlled by microprocessors that send and receive hundreds of signals to onboard sensors. The operator talks with the drone through a controller, sending FM radio signals that the MD4 converts into movement. To get a rock-steady hover, 2 rotors spin in one direction, the other 2 in the opposite. The 2 sets of rotors cancel each other out and keep the machine in a static position. If you drop the speed of one pair of rotors, the torque of the other 2 force the drone to spin. For a straight run, drop the speed of one rotor, which causes the leading edge to dip. Then you bump up power on the back rotor, and away you go. The machine gets all its power from a small rechargeable lithium battery, enough juice to keep it working for about 30 minutes. If the battery runs low during flight, sensors give the drone a pre-programmed flight plan to land it safely close to the operator, who just pops in a new one and sends it up again. And if the MD4 loses radio contact, onboard GPS puts the drone in park to wait for its master. If it doesn't pick up a signal in 30 seconds, it makes an emergency landing automatically. The GPS also allows a user to switch to autopilot for flying the machine on a predetermined route. These firefighters in Birmingham, England, use the MD4 to find deadly hotspots. Cops and security patrols sneak up on bad guys. And it inspects hard-to-get places for hydro crews. Flying around in silence with the latest cameras. It's a stable, floating platform for taking pictures, thanks to the quadcopter design that keeps the shot steady for as long as the batteries allow. If you're a softwood tree, between the ages of 50 and 80, live on a farm, and this machine shows up on your doorstep, you're in for a bad day. This is a feller buncher, a machine that revolutionized the lumber industry. And chances are, it cut down the wood that built your house and made your morning paper. It does the work of dozens of men, cutting up to 4,000 trees in a single day. One of these machines can clear about 100 football fields worth of trees in a week. All with the flick of a joystick. Let's see how it works. The feller buncher has 2 simple jobs: felling and bunching. Cut trees with a big saw, pick them up with a long, powerful arm, and set them down gently. First up, the blade. The feller uses a high-speed disc saw with indents to carry away wood chips, and teeth that are wider than the disc. If disc and teeth were the same width, pressure from the tree would sandwich the blade and the whole thing would grind to a halt. The teeth are made from carbide, a super strong alloy. Strong enough to rip through a ½ meter of dense, resin-soaked trees. The teeth cut through fibers inside the tree with these points. Then, rip out the weak middle section. As the tree is cut, it slides onto this holding plate. Without it, the tree's weight would freeze the disc and burn out its motor. Another great advantage of this machine is how low to the ground it can cut. Leaving behind big stumps wastes a lot of wood. And cutting low is more about reach than bite. Which brings us to the bunching part of this machine and its powerful hydraulic boom. The feller buncher needs distance from the trees to give its operator a clear view for a level cut, and to keep him and the machine out of harm's way. For that, you need a hydraulic arm that's strong enough to pick up and set down a 5-ton tree from 8 meters away. The hydraulic arm has 2 sections, the stick boom and the main boom. Getting these to work together is the key to success out here. With a single joystick, the operator moves and adjusts the boom's 2 sections to land in the right spot and make the perfect cut. Okay, you're through the tree. Why not just yell timber, let it go? Falling trees damage other trees. They're extremely dangerous. And out here, to be efficient, you need the wood out of the way. And neatly stacked for transport. To do all that, you need the hydraulic boom and its claws to be powerful, and you need a body that's not going to tip over. This machine's strong enough to grab several trees at once. After cutting, the operator closes the accumulator and hangs on while opening these clamp arms. When a second tree is cut, the accumulator arms are sandwiched between the 2. A double-hinged joint allows it to slip free and grab the harvest, while the claw is free to grab the next tree. Meanwhile, these special ends, called snouts, keep the blade from accidentally picking up forest debris and sending it flying off in all directions. As the claw grabs, the machine stabilizes itself. It floats on a leveling system that allows the machine to bob and weave on a series of hydraulic cylinders. It's kind of wrestling with the tree as it picks it up and sets it down. With a pivot point near the cab, most of the weight is back here. A great counterbalance to keep the whole operation upright. This self-leveling machine operates on slopes up to 45 degrees. Handy when you're working the side of a mountain. Its tracks provide a great grip without wrecking the forest floor. So tree farms like this one can be replanted. The machine's 31 tons are evenly distributed over 6.5 square meters. At any point, its heaviest impact is less than 5 kilograms per square centimeter. That's less than the pressure you put on the ground as you walk. When the feller buncher arrived on the logging scene in the 70s, it changed the industry forever. The old-style lumberjack is a dinosaur now, and a machine that looks like one replaced him. You're flying over rocks, river currents, and land without a hitch. It's what Hovercrafts do. The HoverTech Rescue Craft is an emergency vehicle working some rough waters in Canada's Fraser Valley. When a call comes in, it's got to unload fast and launch in seconds from almost anywhere. Designers gave this machine just one fan and one motor. And that's a hovercraft rule breaker. A traditional hover has separate fans and motors, one for lift, one for thrust. To keep it compact and light, this machine's single engine does both. Here's how it works. When you start up, the fan blows air into an airbag or skirt made from heavy-duty nylon. Air pressure builds up to the point it has to escape, And the only way out is to push the whole thing up and blast out under the skirt's pockets. You're up and floating on a cushion of air. But you can't go forward on lift alone. At this moment, other hovercrafts need a second fan to move forward. That's because they don't have this. A splitter that divides the fan's air, directing enough downward for lift, while sending the rest out the back for thrust. When you're riding on air, there's not much friction. So all this machine needs is a 65 horsepower engine to hit a top speed of 70 kilometers per hour. You can go just as fast on a boat like this, but you have to push water out of the way and burn a lot more gas doing it. With a hover, you're more aircraft than boat. No current or tide can touch you. Transitioning onto land is no problem. The flexible skirt, made of individual air pockets, moves up and down with the terrain. And if one of its pockets rips, the one beside it fills the gap. And if that one rips, replacement happens fast, like everything else on this machine. For steering, the handlebars are wired to rudders. Navigating obstacles is no problem, and allows the hover tech to reach an emergency fast. But what if it needs to slow down and just, well, hover? A traditional hovercraft can shut its thruster fan and float on its lift fans, but with just one, it's kind of tricky. Kill that fan at full speed, you lose thrust, lift, and slam into the water. Here's the workaround. And it's an idea borrowed from reverse thrusters in fighter jets. These buckets swivel into the blasting air and redirect it forward. Reverse thrust. So no loss of lift or control. The buckets provide pinpoint control when approaching a target. Once in position, killing the fan lowers the deck closer to water. A high-density foam shell keeps it floating while this guy climbs aboard. When it's time to go, adjust the buckets to balance thrust while the fan gets up to full power. Then spin the buckets and away you go. Designers broke a few rules making this hovercraft portable and fast enough for search and rescue work. Pretty handy for guys on call 24/7. Part boat, part plane, the HoverTech gets to the scene fast in a business where every second counts.